First of all, I kind of think for many people when they hear a lot of the discussion about energy policy and saving carbon, people just kind of get overwhelmed by hearing it, and they hear about all the problems and they kind of think, well, what is the solution? Is there another solution? And I'm hoping to explain what that could be today. Just to explain, I am the secretary of the Passive House Association. The Passive House is a house that uses so little energy that if it was freezing outside, 6 tea lights would keep a living room at 20 degrees Celsius with no other heating. So that's how little energy it needs. I'm also a member of the National Scientific Committee for Energy and Sustainability for Historic Buildings as part of ICOMOS. So I'm very interested not just in sort of new buildings, but also historic buildings which can be rendered more energy efficient as well. Now, you've all had the tea break, and if anybody has to go, basically the next 2 slides are hopefully all you need to know. And this is the cheat sheet, okay? So the first point I want to make, we're basically in the centenary now of 1916, and I think that at the beginning of the new state, energy independence was a concept in there. I think we should be thinking about that again, and I think my suggestion will help us do that. Also, the type of energy policy we pursue has real-world consequences. In other words, real people are affected through the bills we pay, but also quite dramatically and fundamentally, people can actually die from it as well. We've made mistakes in the past, I'll point them out to you, and I think we have an opportunity to either avoid them or else to walk straight back into them, and in particular, that covers data centers. Another thing, you hear about so many different targets. It's about energy efficiency, it's about reducing carbon, it's about having a certain percentage renewables. You know, which one are we doing? I'm showing a way that we can more or less get our ducks in the row to actually achieve them all with one policy. My policy kind of centers on retrofitting the existing building stock, and the minister was on, I heard him on the radio on Pat Kenny with Colm, and he came after the panel discussion, and he said, people aren't really interested in energy efficiency because they just don't want to take out a loan on their house. Well, I don't remember taking out a loan to build an ESB pylon either. I mean, you know, so there's absolutely no need for consumers to take out a loan to retrofit their homes. It can be done for free from the consumer's point of view, and we will pay developers to do it by an energy saving tariff. So that's how we'll actually do it. We'll actually copy the wind model. Instead of having a refit, we'll have an energy saving tariff. A lot of people say, God, it's going to take a long time, isn't it? I'll show you an example in Holland where they do it in 1 day. I mean, in theory, you wouldn't even have to move out of your house, but you may as well go shopping and buy all the new things that you can save with the money that you're going to save. The policy, as Fred showed, the amount of energy, the amount of carbon savings are very, very small. So that means we've put in this huge effort building all this wind infrastructure to save a tiny amount of carbon. So that gives us a little bit of headroom, but very little. So if there's one big new demand, it could be agriculture increasing, it could be data centers, as I'll show. All of those savings have been blown out of the water. We're not only back to square one, we're worse off than we started. So again, the policy. And if somebody went into the Minister for Energy and said, you know what, I think I have found not just one carved gas field, but I'm going to find a carved gas field's worth of energy every 6 years forever, that is 0 emissions, that the Irish citizens have all the rights to, I mean, you'd think you'd be biting your hand off. I mean, it would be headline news, and yet that's what I'm going to actually show is actually the case. So if you can remember those 10 points, that's basically the speech in 4 minutes. Okay. So I'll start back at the beginning. Ardent Crusher is kind of like Ireland's Hoover Dam. It's one of those iconic projects. It was the beginning of the new state, and I think there was a real sense of let's do something bold and build what actually turned out to be the world's largest hydroelectric station at the time. It took a massive capital investment. It took 20% of the overall tax take, not just the capital expenditure, but the entire tax take of the Free State at the time. And it produces 83 megawatts of electricity. It's been in the news for other reasons, obviously, to do with the flooding on the Shannon. But I think there was back then a real sense of well, you know, we just got our independence. We want to be literally independent from Britain, but also energy independent. I think they went hand in hand. So 100 years later, where are we? Well, in terms of that expenditure, this is capital expenditure. Expenditure in energy is around 24% of the entire capital expenditure budget. We're now spending over 1.1 billion per annum on effectively the electricity system. You can see the figures there. So electricity, basically from the very outset, has managed to just corner the market and been able to convince government that it needs massive amounts of capital investment, not just once off, but year on year. Some of the points that Fred was making in terms of as you add more and more energy, wind energy into the grid, the costs for distributing that go up and up. And this was actually a study known as the All Ireland Grid Study. And basically the red line just shows where the costs are likely to go as you add more and more wind. So as the capacity goes up, the costs of the grid goes up as well. So we're here, and this is where we're heading. So could we avoid incurring those? Now, as again, it's easy just to talk about costs, but these are figures showing the percentage of people not able to keep their home warm or basically dipping into fuel poverty. And, you know, again, we can look at statistics, but these are real people, and there's another study that shows that there's possibly 2,800 excess deaths. So again, you know, we're not just talking about academic graphs here. These are lives that don't need to be lost. This is a bit more detail on that study. I think I attended a presentation called Power Shift in the Mansion House there late September, and the equivalent of the ESB in Australia, he gave a presentation, and he basically described the electrical system as this is what you see in terms of the consumer and your bills, and this is really the costs and the network and so on needed to back it up. So this is really the hidden side of the electrical generation system. One of the interesting things is when one of the policies M.R.I.A.I kind of signed Ireland up for, the EU wanted us to have a policy in terms of a percentage of renewables. They said 16% of all Ireland's energy should come from renewable energy. And that was broken down into 10% for transport, 12% for heat, and 40% for electricity. So and when you aggregate those together, they turn out to be 16% on average. So he really put the emphasis on electricity, and that's what got us into the position that we are now. Now, the result of that, I mean, is at one level it's a good thing because people actually had to go out there and say, what will all this cost? And one of the submissions the ESB made on the green paper there last year, was actually at the end of 2014, I think, was this submission where they expected, if you remember the first slide, they're getting about $1 billion a year at the moment. They were projecting between now and 2030, so over a 15-year period, they would need $55 billion. So that's gone up 3 times in terms of what they were typically getting. So that's just a sort of good number to have out there. Colin was talking about when they built Money Point, and like all power stations, all thermal power stations, a lot of the energy that goes into generation, about 65% of that is lost as heat energy up the chimney. Now, in some European countries, they're able to harness this by having what they call district heating, where they run the steam over pipes and they basically distribute that to homes, provide free heat. We didn't do that in Ireland for a variety of reasons. One, just to do with geographical location of the power stations, but that was a missed opportunity. So that's one that I think we could reverse. So recently we've had the output of COP21 in Paris. So we've got that now on top of the EU directives on renewables, energy efficiency. There's also a thing called market integration. So there's a lot of things going on, but the one thing that's going to be key is that the emphasis is now going to change to carbon reduction. So we've got to sort of think in terms of the Irish situation, what is the best way for us to reduce carbon, given the idiosyncrasies of being an island and the problems of generating our own electricity and really having very little interconnection, and even interconnection doesn't really provide a technical thing called inertia, so we have to basically balance our own system. Now, just very quickly, I won't go through this in detail, but basically the outcome for Paris was that, the EU is looking, and we're basically going to have to go along with the EU, of dropping 40% of our emissions by 2030 and 80% by 2050. So that's a huge task. And as Colin pointed out, I mean, even with all the efforts of that, we could easily be blown out of the water if China or India failed to do that. So we've kind of got to think, how do we box clever? How do we reduce emissions in the most efficient way for us that gives us the best benefit, regardless of what other countries do? It doesn't mean we don't do it, it just means we do it in an efficient way. Now, it was very good to see Fred's presentation. When I kind of started looking at emissions, this is purely the emissions from the electrical system. So what we have at present is about 11.5 million tons of carbon being emitted for a generation of 25 terawatt hours of electricity. That's 25,000 gigawatt hours of electricity. At the moment, there's 5 terawatt hours of wind. That's 20% roughly. So this is the current line of emissions. And using Fred's figure of about 8.6% of actual carbon reduction for 20% of physical capacity, the estimated savings of carbon is about 1 megaton of carbon. So it's quite a small reduction for the addition of another 20% of wind. So the point is, could we possibly look at another way of spending the amount of money that we're going to spend on this and get either the same or a better reduction in carbon? And would that be possibly a better way to go? Now, just another thing, again, Fred mentioned it, but there's a maximum amount of wind and indeed solar. If you add the two together, it can't exceed 40%. And that's basically a thing to do because if you remember back a while ago, people were experimenting with putting grease in their diesel engines. They put in an additive. They have a certain percentage of chip oil and diesel, but they wouldn't go over a certain percentage or the engine would start to plink. Now, that's just an analogy, but essentially it's the same with solar and wind. If you go above 40%, you risk the whole grid system actually collapsing. So you've got to think of that as a hard limit. So I want you to bear in mind these two facts. We've got a 40% hard limit, but it's a percentage of our demand, and we've got a very small saving there. So, and as Fred, again, these slides are done for another presentation, but what we've seen is at the bottom here, this is the percentage of electricity from coal. After that, you have peat. After that, it's fuel oil, and then gas. And what you can see is over the years from 1990 to 2015, I think that is, a huge growth in gas. And then you can see the renewables up here in green. So really what you've seen is, with the advent of renewables, you've seen a huge shift to gas. And most of the CO2 savings have actually been to do with the addition of gas. People often think, well, how come wind doesn't save much energy? I often think, how would you measure the emissions of the Tour de France? Would you just look at the cyclists? Or would you maybe think, oh, hold on, there's a whole pile of cars following them around? And that's effectively exactly what's happening with wind. There's a hidden component. Everybody sees the wind turbine and thinks it's not clean and green, but there's a whole pile of cars following it behind. And again, when you look at if anybody's in business, you might have 10 staff on the payroll. If you fire the 2 cheapest employees in the company, you've reduced your cost by 20%, but you haven't reduced, you've reduced your staff by 20%, but you haven't reduced your cost by 20%. And so it is with the way we're generating. Coal is still in there with Money Point. We actually have peat and so on. So we're actually, if you like, firing the most efficient people and keeping on the dead wood in a way. So, to kind of get this back to maybe slightly another corny analogy, think of, having your slice of toast in the morning. So you have one slice of toast and you have your traditional butter full of fat. It's great stuff, but that's what I have. And suddenly the doctor tells you, you've got to get the old cholesterol down. So what do you want to do? Do you want to have one last slice of toast? No, you go off and you buy one of those expensive butters, Bennycull or whatever in it. You pay a bit more for the butter, but by God, your lifestyle hasn't changed. So you're more expensive than you're still at the one slice of toast. That's effectively what we've done with the wind that we've put in at the moment. we now have a more expensive sort of the penny call electricity. Okay? And of course, what somebody said, one wag said to me, this half-foot butter is great because you can spread it on twice as thick, you know. And, so you kind of think it's a sort of victimless crime. We'll just keep adding more and more to this. It's great stuff. But of course, you can't have just another size. As Fred pointed out, you can have about 8.6% more before you're back to where you started. So all the savings. So all of the, sorry, that should be 8.6%. So what you're really looking at in terms of this graph, so at the moment, as I said, this is our emissions here. If we put in another 20% of wind, we'll get them down to here. But as you can see, that's with 25 terawatt hours of demand. If our demand starts to go up again, we're back to square one. All of that has been for nothing. In other words, if we have an extra finger of toast, we are toast. So we're at this crossroads of where we've been doing this policy of adding more and more generation with increasing cost and complexity. And as you can see, it's a dead end because you get back to square one and worse. Or is there another way? So I'm just giving on time here. So I think there is, and it's a huge opportunity both for Ireland, for individuals, for business and so on. What I have here is just a series of screenshots from Google Earth just showing aerial images of Dublin, Cork, Galway and Limerick, and it doesn't just apply to cities, it's any type of building. What you probably can't see very well there, but there's huge repetition in housing estate layouts in the cities. And even in the countryside, since I've kind of come up with this policy, like I've been literally scanning every single house, and there's so much repetition in the one-off houses in the country. Many of them are built from pattern books. So, really there aren't that many different types of houses to kind of get to know. Now, the funny thing about electricity, you might hear this figure, about 40% of energy goes into buildings, but 70% of the electricity goes into buildings. And 75% of that 70% is into the residential sector. So it accounts for about 50% of all electrical consumption. And I think that's often forgotten. Funny enough, in all the years of being an architect, I never really kind of thought how much electricity goes into buildings. And another thing is if you get a B.E.R. cert, a lot of the electrical use in your house is not counted in that B.E.R. cert. It doesn't count your appliances. It doesn't count any lighting that's plugged in as opposed to hanging from a ceiling. So it's a whole pile of things that aren't counted in that. So you're kind of getting a false picture in terms of what your energy consumption is. So, as I say, what we can do with a passive house is we can really get down, we can save 90% of that energy quite easily. These are the figures. So, as I say, the buildings we're using in terms of all the energy, and this is one of the key points I want to make. I know I'm focusing a lot on electricity, but the passive house will also save your home heating oil, the peat, the turf you're burning in the fireplace, as well as electricity. So in terms of carbon emissions, I'm not just talking about electrical carbon emissions, I'm also talking about non-electrical. So essentially we can get the 40% of the energy we're consuming, and also we can have a look at the buildings that go into buildings for insulating them, and we can turn that 50% and reduce it down to 5%. Now just think if you're setting out to build a whole pile of wind farms, are you going to build them for the 40% that you're currently consuming, or do you want to build them for the 4% that you could get down to consuming? In fact, if you think of the world at the moment, we've got 7 billion people in the world. We could get the energy demand down to what 700 million people are currently consuming. Or if you want to think of it in an Irish context, the entire Irish demand could be supplied by the county of Limerick's current consumption. So there's real savings to be made here. So there's a scientist in America called Amory Lovins, and he came up with he actually saw a typographical error. He saw NW instead of MW. M meaning megawatt. He saw, I wonder, does that mean a negawatt? In other words, saving a megawatt of energy. Of power in that case. So I kind of borrowed that phrase. I quite like that. And it has huge implications. We're talking about Ireland today, but it applies to all of Europe. The import bill for Europe is 400 billion for energy. So we could drop that. We could save 136 billion for Europe. We can save 2 billion for Ireland. We'll get back to Ireland. Our energy import bill is 6.5 billion. We could save 2 billion off that. So how do we generate megawatts? Well, we saw Arctic Russia. They built a very expensive power plant, biggest hydroelectric dam in the world. How do we do it? Well, we just insulate buildings, and that would be the equivalent of building 3 Arctic Russias every year by just simply insulating buildings, and I'll show you how we do it shortly. And as I said, the savings are not just electrical, but they also deal with the heat element as well. And that's another point, that those 3 figures I gave you that build up to 16%, 10% on transport, 12% on heat, and 40% on electricity. We've made up most of the running electricity. We're hardly anywhere in heat, and we're kind of a tiny bit of biofuel in transport. So we're really exposed in terms of the fines that might come in for that. But basically, how do you generate megawatts? Well, in a way, I think it's a key skill of a sort of energy architect, that you would sort of look at a house and you might say, well, yeah, okay, for that house, I might just put something in the basement and something in the attic because I like it, it's historic, and that's the most efficient way to do it. Or you might say, well, it's not too important on the outside, so I'll wrap it and I'll give it a new facade on the outside. Or you might say, do you know what, I'll take the roof off and build a new pod on top, put in some solar panels. Or you might decide just rebuild the whole house. And you'll sort of make those different judgment calls for each of the different building types. But as I said, once you've done that exercise once, because of the repetition in the building system, it will apply to them all. So where will this take us? As I said, with the demand for residential, we could basically drop our demand for electricity by half. Now, one of the key points about that is, if you remember the 40% hard limit in terms of the renewables, the 5 terawatt hours of wind that's already on the system will be 40% of that reduced demand. Now, the key thing about that is, if we're serious about energy efficiency, every single turbine more that is built will become surplus to requirements if we reduce our demand, because we can't have more than 40%. And we can't really export it no more than, as I was saying to Colin earlier, if you put milk in your coffee, can you sell the guy the milk from the coffee? You know, they're all mixed up. So basically, that hard limit will basically affect our entire electrical system. So why would you build any more turbines if that is the case, if we can go down this energy efficiency route? And more than that, because we don't have to build them, we can use the money that we would have used to build them to insulate the buildings. And I'll give you the economics of that. And as I said, the amount of energy is equivalent to the R.I.B.A. gas field. We would save 4 megatons of oil equivalent of energy every year. The R.I.B.A. gas field has 24 megatons, so that's every 6 years we would save the equivalent amount of energy that's in the R.I.B.A. gas field, but there's no emissions in it. So it's a huge opportunity, and this was a presentation I originally gave to architects, so that's why I was emphasizing the architects. But it's not just for architects, it's for all of us. There are many, many examples of, like the Empire State Building in New York. You couldn't get a more iconic and historic building than that. They got their energy demand down by 38% just by changing the windows. And on other buildings, they've got 70% savings. This one's 63%. They've got up as far, and this is in America. And America, as I think Colin pointed out, they wouldn't exactly be car-carrying tree huggers. I mean, they're businessmen. They'll go out there and they'll do this because this makes sense. And that's why I want people to do this. You know, there's only so much kind of eco-earnestness we can take. We can actually save money and be more comfortable. I mean, that's, you know, and then it's easy. Now, so how do we do this? As I said, I gave away at the beginning, we can do it very quickly in one day. And what I want to do now is quickly switch to a video that shows you this being done. Okay, so I'll just briefly pause. So what you're seeing here is a very typical house that you might find around Dublin, Cork. I actually have a house here in Clonmel, and there's actually a strip of houses like these in Clonmel. So they're all around the country. So what you're seeing here is the components that are being loaded onto the truck. So this is going to be carried out in one day. So this is just in the factory the day before, so loading them up. This is the guy on site. Just to explain again, what would happen is if you want to get your house done, somebody will visit your house 3 weeks ahead of this actually arriving on site. They'll take a perfect scan of your house. It's almost like getting a crown on your tooth. They'll do a scan of it. They'll have all the dimensions of it. They'll go off to the factory. They'll make this wrap, and then they'll come back and fit it in one day. And the points that they fix it to are predetermined. So this guy is just putting in place these fixing points. So you can see the windows are already in the walls, pre-fitted. So being efficient Dutch people, they arrive early in the morning. The only real intervention in the existing house is they have to take out the existing windows. That's basically the only kind of major thing. You don't even have to move your furniture. People leave the pictures on the wall. I mean, effectively, they nearly leave the TV on and they could stay in. There's no scaffolding required in the traditional sense. So these are just craned into position and dropped onto those fixing points. All of the existing services are bypassed and they put in a new services again on the outside of the house. So your plumbing and electricity is there. They're just fitting a window trim around where the old window came out. And because that facade is further out, they just bridge the gap. Exactly the same with the roof. They strip the roof covering, put another layer on top of that. And in this case, they not only made it a passive house, but they made it zero energy. So it supplies all its own energy. So they put photovoltaic on the house. And so you just see the rails. This is just a ridge piece, a capping piece for the ridge. This house is an end of terrace house. So in effect, what you're looking at is what would happen for a semi-detached house. I just pay special attention to this. This is a new service pod that goes at the back where they can put in hot water, boiler, all the different services they need. But there's another use of this that I want to talk about in relation to data centers. So just remember that particular image. The membranes you can see provide airtightness. They just stop drafts getting through the house. And here's the finished product. In this case, it's finished in timber, but it could be in brick, it could be in plaster, it could be in render. In fact, what's happening in Holland is they're actually offering people, what do you want your house to be finished in? In this case, it's a full PV roof, so it supplies all of its own electrical requirements. And you see those new pods on the back. Yes, at the moment that's 65,000 per house, and they hope to get it down to 45,000. It can be done for 30,000 if you don't put in PV. So that's a choice you can make. So I'll just get back to. Okay, so 12, 11 minutes. Right. So back to that crossroad. So as I said, we had on the left-hand side this sort of dead end. On the right-hand side, what I'm showing is by reducing demand and improving efficiency, we can actually go down the route of reducing demand so that the current wind that is there will become the 40% of the now lower capacity. And we use the money that we would have spent on the wind to actually pay for this retrofit. And I'll show you those figures actually that I just gave Fred are very useful because there's about 1 million homes in Ireland, and if we spend that need this deep retrofit, and they waste most of the energy, and if we spend 1 million homes by 45,000, that's 45 billion, whereas the amount being planned for electricity, well, actually, here's the figures. So on the left-hand side, the choice is we carry on the current path. As you see, the ESB are suggesting that they're going to require between now and 2030, 55 billion. Wind farms at the moment, the wholesale market in electricity is about 2.5 billion. So wind farms get 20% of that at the moment. These are very rough figures, but so they get 500 million. If we add another 20%, it stands to reason they'll get another 500 million. So 500 million over 15 years, that's 7.5 billion. Another extraordinary fact is at the moment we're paying out about 450 million every year in fuel assistance payments to people who can't afford to heat their homes. Now, the St. Vincent de Paul actually in one of the energy paper consultations said that had that figure kept pace with inflation, that would be 800 million a year. So even if you take a mid-figure or lower, say 500 million, again, between now and 2030, that's another 7.5 billion. After that, you have the fines that might be imposed, and there's just one small typo here. The fine, the EPA and the SEAI together have calculated the fine that we're likely to incur for not meeting our targets by 2020, and they estimate it to be about 1.6 billion per year. It's about 200 million per percentage point that we missed the target by, and I've picked a low average there. Now, the fine will only kick in for 2020. I actually calculated from today, so that should be 16 billion instead of 24 billion. But so if you take that off, we're still talking about 84 billion for going down the adding capacity to the system. On the other hand, we can go down the retrofit. As I said, it's about 1 million homes. I'm particularly focusing on residential. Business and industry certainly can look after itself, but I think the residential is the most difficult to crack, and everybody thinks people have to dip into their own pockets to retrofit their own home. That isn't what I'm suggesting, and I'll show you why. As I said, the cost, if you don't put in PV, is about 30,000. If you do put in PV, about 45,000. So 30 to 45 billion over the same period. But the savings on fuel imports would be 2 billion once it's fully rolled out. You eliminate fuel poverty, which means people are not dying anymore. You avoid paying the fine of 1.6 billion from 2020 onwards. So you're talking about a saving of in the region of, about 40 billion. Mark Zuckerberg kind of recently gave away about 42 billion, I think, so we haven't quite matched that. But, here's 40 billion that we're just going to give away needlessly. Now, I just went through the bank crisis like everybody else, and I tell you, I got caught badly on it, and I realized we do stupid things and we don't realize it till it's too late. I don't want to do this again. I don't want to be hearing that, oh God, why didn't somebody tell us this? Well, spread the word. We're going to do it again. So that's a slightly more complex analogy. This is even more simple. Just on the left-hand side, we continue to add megawatts. There's no reduction in demand. Your bills will go up. There's minuscule savings in carbon dioxide, and we're likely to be fined for missing our EU targets. Or we generate megawatts by saving energy, at least a 75% reduction in demand and CO2, and that's both in electrical and non-electrical. Energy bills could drop by at least 1,875. So for everybody's pocket, that's how it will improve. In terms of the average industrial wage, it's over a 10% bump. And if you're on the pension, it's like getting 20% bump. And if you're a high earner, that's after-tax income, you can more or less double that. And we will actually meet all our EU targets because the reduced demand now becomes 40% with the wind that's there. Now, you might hear this phrase, every time I mention this, you hear these kind of mantras coming out. Sure, we can do both. Well, I often think, look, follow the money. If we've done both, we've spent the same on both. Since 2000, they've spent 136 million on energy efficiency. Compare that to 1.1 billion per year since 2000. That's 15 billion. When we have spent 15 billion on energy efficiency and haven't built one turbine more, then I say, okay, come back and have a look at the policy. But basically, we need to stop now, switch the money into this, and then come back and take a look. We've only been doing one. So we've got Now, I'm just running a little bit out of time, so I want to get on to this. How would we actually do this? Now, again, I think it's worth looking at the wind industry. How did they basically went from a standing start to over 2,000 megawatts in about 6 years. And they did it through the support mechanism called the Renewable Energy Feed-in Tariff, or REFIT. The developers get paid this for 15 years and there's a guaranteed tariff. So why couldn't we copy this? So what we do is we say to the market, okay, we're going to give you this rate for saving energy, and let's call developers, could be anybody, it could be you and I, it could be a community, but let's say they're the big guys like the Six and the McInerney's and all the guys. I know a lot of them are in NAMA, but anyway. We say, okay, you go out and identify as many houses as you want. What they'll do is they'll come along to you, you're in your house, they say, do you want your house retrofitted for free? You get to keep all the energy savings. And you might say, well, dear, that guy from Cisco, he's a much nicer brochure and he was going to give me a weekend in the hotel. You know, it will be the market. It'll be up to them to come and convince you to do it. Nobody will force you to do it. But if they can convince you to do it and they achieve those savings, they get paid so much per megawatt saved. They get paid for 15 years, and that allows them to raise the capital to retrofit your home. So what I'm saying is, by kind of going down, by taking the wind model and using it for energy efficiency, we can actually achieve a lot of what they have done. And again, nobody has to lose money here. The only people who really lose money is if you're making a wind turbine, yes, you're not going to sell them anymore. And if you're making some pylons or cables, you're probably not going to be in business. But apart from that, in fact, it's going to create an awful lot of real jobs right around the countryside, not just concentrated in Dublin. And as I said, developers aren't just the classic people we're talking about. It could be a local authority has no money. They just say, we've all these social housing, we have no money to refurbish them. They get in a guy, he gets paid this new fit tariff, as I'm calling it, which stands for negawatt. That's where the NEW. So I just want to kind of briefly move on to data centers. If you remember on the slide where I said if our demand energy goes up, then we're back to square one and worse. Well, data centers are likely to do exactly that. Recently, permission has been granted for Facebook. Facebook uses 108 megawatt of energy, of power, and that is the same as every single house in Dublin City. So that's just one. And I've plotted that on the graph here in terms of what it does. So as I say, we're at 25 terawatt hours. This is the extra headroom that we've got in terms of all the wind that we put in if we go to the 40%. I mean, at the moment, it's already pushing us over what we've done to date. So this is what Facebook will do, but Apple are also planning one, and M.R.I.A.I, and this is what Apple does to our demand. So they're going to basically blow us out of the water, and they're claiming that they will be entirely powered by renewable energy. That's an impossibility, as I said. It's like putting milk in your coffee. You can't just sell the milk once you put the milk in the coffee. They have to buy it like everybody else off the grid. Whereas really what we would like to do is reduce the demand and then maybe look at adding Facebook and Apple on top of the reduced demand. As you see, we've plenty of extra headroom in terms of our emissions have still come down. But wouldn't it be even nicer to get these guys on this side of the black line? And I'll just talk briefly about how we will do that, if you follow what I'm talking about. Now, this is a traditional data center. Essentially, it's a big hall with piles of computers on either side. And the reason they come to Ireland is they don't need air conditioning. They just let the heat escape up the roof and out into the air. Now, if you remember that chimney I showed you, the power station at the beginning, basically, that's a mistake we made then, and this is a mistake we could be making again now. How could we harness the heat from this and use it in a useful way instead of adding to our demand? Well, in Germany, what they're doing is they're now building houses with a small data center in the house. It's about the size of a large American fridge, and the heat from that is either put into hot water or it's used to move around the house to preheat the fresh air coming in. Now, if we do that, then the actual demand, the overall demand won't increase. We'll be moving the Apple and the Facebook onto this side of the line. So we're actually, it's kind of like the way the Chinese cook, they use everything. They even use the chicken feet instead of just kind of taking the breasts and throwing everything else away. And so the point is, by kind of coming up, and if you remember that little pod I was talking about in the video, that could be tacked on the back of each existing house and provide all of the heat and hot water for free in the house. So not only would you have reduced energy bills, but you effectively have no heating bills, and the only bill you'd have is for any residual electrical load you have. But I suppose my key point is what we've got to do in Ireland is kind of think, yes, we've signed up to international agreements where we're going to reduce carbon, but we've got to do it in a way that makes the most sense for us, so that, as Colin said, if China or India decides not to achieve its targets, do you want to be looking at a windmill with higher bills, or do you want to be sitting in a very comfortable house looking out and say, well, we did our best, and you know what, it saved 11 times more carbon anyway, and I have practically no heating bills, and I'm very comfortable. And I think this cartoon sort of sums it up. You know, if this global warming is a big hoax, you know, well, you know, we've created a better world for nothing. Well, you know, it's a win-win, isn't it? I mean, there's no downside to doing it this way. Thank you.